Okay, on this question, we have to ultimately rewrite p of x as a product of linear factors. Because it's a cubic, I can hope to get this into as many, but no more than, 3 linear factors. Um, the big clue, the breakthrough they give us is they tell us a known factor is x minus 2. And that's code for, hey, the remainder is 0 when divided, I should say, when p of x, is divided by x minus 2. Okay, so that's what, hey, if I know it's a factor, that means that thing's going to divide in there perfectly. And let's see what that looks like. So the reason we want to carry on with the division is because we can get a quotient that is the leftovers. I've said this in class before, but let me pause right here for a second. But when I tell you, hey, 168 has a factor of 7, 7's a factor of 168. Go find other factors. Well, the first thing you do is you take 168 and you divide it by 7, and you get 24. And then you can start to parse 24 apart, and that's not too bad because 24 is a much more manageable number. Same tactic here with this cubic is we're going to divide the cubic by the known factor in order to get some quotient that we know we'll be able to work with and factor further. Okay, so let's get right into the division here. What do I need to multiply x by in order to match up perfectly with 3x cubed? I need a 3, and I need 2 powers of x. Multiply that by x, and you get exactly 3x cubed. Carry on that multiplication throughout the divisor, and you get minus 6x squared. Subtract those like terms, and you'll eliminate the first set as you desired. That's how we came up with this. But then negative 5x squared minus negative 6x squared. So it's a double negative. You'll end up with positive 1x squared, and then just drop the next term down so we have enough terms to compare with our divisor. So we focus on the front term again, 1x squared. In order to multiply x by something to match up with 1x squared, we need a positive x up here. So positive x times x is 1x squared, and positive x times negative 2 is negative 2x. Then we jump into the super subtraction here again, and we get the first elimination there. Then we have negative 4 minus negative 2, so double negative there, end up with a negative 2x. Drop the last term, plus 4 down. And now we refocus one last time. How do I get negative 2x when multiplying by x? Well, I need a negative 2. So negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. And the predictable result of a 0 remainder is finally here. So everything eliminates, and that tells me that we have a quadratic quotient that I am going to seek to factor all the way. So the goal here is to get this factored into binomial, two binomial expressions, linear binomials, and that's difficult because of the 3 on the a coefficient here. Now, 3 is not crazy. You can go 3x times x, but where it gets a little bit more intricate is where do I put the positive or negative factors of 2? Which way do they go? This isn't too bad, actually. You could probably brute force figure this out with just trial and error. Probably in 2, 3 at the most tries, you would have the right answer. But I'm going to use this as an opportunity to work on our AC method. Okay, the AC method is named that because what we do is we look at the a coefficient and the c coefficient, and we multiply those together. A times c in this case is -6. And so we take -6, that line, we take -6, and we're going to look for the factors, things that multiply to -6. But we're also going to sift through these values with the b value in mind, which is +1. It's the coefficient on that linear x. So we want to know what factors of -6 add up to +1. Okay, so we can start listing these out. -1 times 6. If you just go at it blindly here, that adds up to 5. So that's no good. I'm gonna cross that out. Adds up to 1. So I'm thinking it's a 2 and a 3. So I gotta go -2 times +3, because the 6, has to be negative. -2 times +3, but those add up to +1. So we found it. That is the AC method analysis I'm talking about. And so you might be thinking, okay, great. What does that mean? What do I do now? I'll tell you. This, let me carry this down here where I have some room. This quadratic, 3x squared plus 1x minus 2, can now have that middle term split. So split the middle term is another phrase you hear. And I'm going to rewrite 1x as it's going to be minus 2x plus 3x. I'm just stealing those numbers from my analysis up here. Okay, and then of course we have the 3x squared term didn't go anywhere, and the minus 2 at the end. Those just carry down. You're just splitting that middle term, okay? All right, so as you consider this, now we do what's called factor by grouping. Okay, factor by grouping means you're going to take the first two numbers in the expression, the first two terms, and factor those as much out of those as you can, and then the last two terms, the lower degree terms, and do the same thing. So what does 3x squared and minus 2x have in common? Well, they both have factors of x. I can't pull a 2 out of the 3 or vice versa, so I could pull an x out, and what that leaves behind is a 3x and a minus 2. Okay, now we're going to do the same thing over here, so to speak, with the 3x minus 2 in this grouping. And you look at that and you go, well, 3x has nothing in common with -2, neither an x nor a factor of 3, so except for 1, okay? This is the thing. When you feel like you're at a dead end with factoring, you can always pull a phantom 1 out, okay? And so 3x times 1 is 3x, and -2 times 1 is still -2. The beautiful thing about factor by grouping is once you get those two little groups factored, you will see, you will see a common binomial factor become visible. So 3x minus 2 is a common factor, and the other binomial is from what I call the leftovers, or the structure that's left behind. Okay, so that's the x plus the 1. So this is our factorization for this right here. Okay, that factors into that. Now, back up at the beginning of the problem, we were asked to factor completely, knowing that x minus 2 was a known factor. Okay, so what you could do now is bring these other two factors that we found and populate the total factored form. So 3x minus 2 and then x plus 1. All right, I hope that helped. That's a recap of AC method analysis and factor by grouping by splitting the middle term.